You are listening to the Information Security Notes and Podcast, episode 21, originally released on August 21st, 2020. My name is Amishav. This week we have HD Moore on the show. HD is probably best known as the founder of Metasploit. He's a prolific researcher, and today he's the CEO of Rumble Network Security. Our discussion focused on asset identification. I think the three main takeaways are: one, some techniques you can use to figure out relationships between domains, meaning how to correlate domain ownership without relying on whois information, which in our GDPR world is no longer available. We also talk about moving beyond fingerprints to figure out what a device actually is, and not just what the OS it runs. And finally, why local networks are only growing and getting denser, even when the trend is to move everything to the cloud. Direct support for this podcast comes from BreachSense, the data breach monitoring platform. What's the easiest way hackers break into your network? By using valid usernames and passwords. Attackers collect millions of leaked credentials from almost daily data breaches. Without visibility into which of your employees or users' credentials have been leaked, it's tough to protect against this. Integrate BreachSense's powerful yet easy-to-use API into existing security solutions to prevent account takeover and stop online fraud. HD Moore, welcome to the show.
Hi, thanks for having me.
It's great to have you here. I'd like to start the show with a bit about your background. So how did you get into InfoSec?
Yeah, sure thing. So I mostly got into security from the BBS scene. So, everything from like dialing to bulletin boards and reading text files to word dialing and just kind of exploring the whole telephone network that I could find. And that eventually led me on to, IRC. And, once you get on IRC, your life is over. Now you're a security person, apparently.
Awesome. Okay. So you mentioned that you were doing a lot of internet scanning, and you were involved with the Sonar project a couple years ago. How does that differ from, like, if somebody wanted to just run mass scan against the internet, how is that different from what Sonar is doing?
Oh yeah, sure thing. So mass scan's amazing. ZMAP is amazing. There's a whole set of tools out there that are great for doing internet-wide scanning. What Sonar does is does all that for you. So that's a project being run by Rapid7 still. It's about 4 or 5 years old now. And the idea is they scan all of the IPv4 space either daily or weekly. I forget the schedule these days. And the great thing is they publish all that data on, in bulk form. So you don't have to go to a search engine and search it out or try to find things. You can go download all the raw data from all those scans from the open data platform, which is, I think, like opendata.rapid7.com. So the great thing is they're giving away all that data for free. You can use it for your pen test, use it for assessments, use it to kind of monitor the exposure of your own environment. It's a great research data set if you're trying to figure out, what banners are out there on what ports. So the big difference is you can always use mass scan or ZMAP to scan everything yourself, but doing internet-wide scanning is complicated, it's costly, and results in lots of hate mail. So if you don't want to deal with that, you can just go grab the Rapid7 data set. And if they're covering the ports and services that you want to look into, there's already a data set available, and they keep producing new data sets. So you can start doing historical and time series analysis on it. So it's just an amazing data set. And it's being provided for free to the community. And I think more folks should take advantage of it.
Awesome. Now, let's say you did want to access ports that weren't in their default ports. What are the gotchas when you run something like a ZMAP or mass scan that you should be aware of that you can fix in order to be able to do a internet-wide scan?
The big ones are just starting off with the IP space itself. There's only, there's 4.2 billion IPv4 addresses, but only about 3.7 billion are usable. Of that 3.7 billion, I want to say there's like at least 500 or 600 million that are never going to have anything in them. That are just going to be dark space that aren't being mapped to anything, that are full of honeypots. So knowing what IP space to scan in the first place is really tricky. You have to go carve out all those special subnets. Keep in mind that IANA has actually changed a lot of those recently, so or even ARIN in that case. So some of the special IP ranges that used to be considered reserved are no longer reserved. They've been pushed back to the whole internet. Just like 1.1.1.1 used to be a reserved IP, now it's being used by Cloudflare. So in the last just 2 or 3 years, you've seen a big change in reserved IP space now becoming publicly routable and publicly visible. Another thing you'll notice is that a huge portion of IP space, I don't know the number offhand these days, is owned by the 3 big cloud providers. You're seeing huge amounts of IP space owned by Amazon, owned by Microsoft, owned by Google. And keep in mind all those. So the good thing about scanning that space is that it's super dense. Almost every single IP is in use by something. There's always a computer at the end of the line in those IP spaces. The bad news, though, is those providers can easily just block your source. If they get sick of you, they can block you Amazon-wide pretty quickly. So keep that stuff in mind. It's really that's most of the challenge there is, one, you have to have a host provider that lets you scan fast enough and doesn't kick you off for running scans. If you try to scan from Amazon VPCs, for example, they don't seem to work very well for scanning of any sort. Like trying to even run a Nessa scan, Nmap scan, out of an Amazon VPC, even one on a fairly well provisioned instance, you're still going to have a pretty decent drop rate on your packets. And I just spent the entire week trying to figure out why my packet rates were so terrible coming out of AWS VPCs. Ends up it's just AWS. That's just what they do. So if you move to a different provider, either a bare metal provider like Single Hop, Hetzner, OVH, or to go to a provider like DigitalOcean that's pretty scan friendly and has really great nodes.
I think you just got cut off there. You mentioned before that part of the IPv4 address range is black hole. How can you figure out where, if you want to scan the internet, how do you figure out where to focus your efforts?
It's a good question. As far as I know, there's not any public list of what IPs to scan and not to scan. You generally make that list on your own as you start scanning, and it changes quite often too. Like I feel like in the early days of Project Sonar, a lot of other third-party researchers would approach us and say, hey, we have your scan exclusion list because we don't want to hit the same things that you guys are hitting. And our viewpoint was always like, no, you should probably hit them anyways because they might have changed already. Like we would have organizations say, you absolutely cannot scan this. And then they would, have staff turnover 2 or 3 years would go by and we would still have them on our exclusion list. But the new people who are running the company may not care that we're scanning them. Attitudes may have changed, but we'd already told those folks we would stop scanning them. But, it didn't make sense for us to kind of push our blacklist on everybody else at that point, our exclusion list on everybody else. It was something where it's almost better to understand that. So that's one way to look at it, which is that you should always scan all 3.7 billion addressable just to see what comes back and then figure it out yourself. The other way to do that would be to look at the Shodan data sets, look at the Project Sonar data set, and do search queries against those against different net masks and look at what the count numbers are. And if you start to see giant holes appear, there's probably a dead space there. So for example, if you go into Shodan and search for 1/8, 2/8, 3/8, and going all the way up, you'll see some of those spaces have almost nothing in them. That's a good way to kind of tune your scans and say, well, why should I scan 44 dot when there's nothing in there, or whatever the big ones are. There's still some large companies that have an entire /8 where very little of it is externally reachable at this point. So on one hand, it may be better to avoid those subnets entirely. On the other hand, maybe you want to explore them anyway to see what comes back. That's the great thing about internet scanning is you never know what you're going to get, right? It could be anything.
Okay, and in terms of never knowing what you're going to get, when you need to track down a geolocation for a specific IP, when the IP ownership is fluid and it's moved from country to country, even within the same day, how do you handle that?
It's tough. So generally the GeoIP lookup list, things like the MaxMind data set, those are being updated pretty frequently. But some subnets actually change ownership, almost daily at this point. I remember looking into an incident a while back where someone's using a satellite provider and the the country associated with the IP subnet was actually being swiped out back and forth multiple times per day. So sometimes it would show up as Jordan, sometimes it would show up as Saudi Arabia, sometimes it would show up as Iran. And the only reason we notice it is when it would happen to be allocated to Iran, it would pop up all of our alerts saying, hey, here's a country we can't do business with. But when it was being mapped to Jordan and Saudi Arabia and so on, we'd see this range like, this one doesn't look right for some reason. And we realized, it's because this previous subnet was mapped against Iran. So the only way to really do that is to keep historical archives of IP geo databases. And then when you run a scan, always correlate that scan against the time relative database. So for example, if you're doing weekly scans, you need to take a weekly snapshot of MaxMind and always correlate those two things going forward. Because 3 or 4 months from now, when you go back and look at that IP address, its country association may be totally different than it was 3 months before. So you have to always look at the historical database. That's a point in time match for when you gathered the data. And that's a huge problem for folks doing threat intelligence these days. Oftentimes you've got these big IP databases that are considered bad, but they're all very time sensitive. And if you don't look at the time context as part of that, the data doesn't make sense anymore.
Okay, and you started a project a couple of years ago called INetData. Can that be used to monitor things like geolocation?
I don't think it has support for geolocation. The INetData product was more of just a way it's a bunch of wrapper scripts. It's open source on github.com/hdm INetData. And what that project does is grabs automated downloads from multiple data sources, and then uses a bunch of utilities written in Go to process that data into easier to query formats. So for example, you can take the Sonar FDNS data set, which is somewhere around 2.4 billion records, if not more than that, for just the A record responses, and turn that into a lookup table that's almost instant to query. There's no more like multi-minute grep-Rs across your directories. You literally just do a mquery lookup against it. Mquery being this little utility that queries M tables. So the idea behind INetData is that one, you should regularly gather data from all these different sources, whether it's MaxMind or whether it's Aaron or whether it's RRIP sources. And then once you have that data, you should crunch that into a format that's much faster and easier to query. So if you have a license for Aaron bulk whois data, for example, there's some tooling in INET data that converts those into JSON files that are much easier to process.
Okay, so what was your thought process for choosing Mtable over something like LevelDB or Mongo or Elasticsearch for the data store?
For the most part, it's all key value stores. When it comes down to it, almost every fancy NoSQL store out there is just a key value database. And the trade-offs really are how often do you have to update? How often are those databases updated and how quickly can you query them and what do they scale? For Elasticsearch, I tried throwing some early Sonar data into Elasticsearch and it melted down immediately. Like Elasticsearch, I'm sure there's a use case out there where it works for people, but I've never had a scenario where all my clusters didn't melt down a week later. Like it seems to be tragedy in the making. It's like using Mongo. You just don't do it. Like it looks amazing to start. It's always good pre-prod. And as soon as you go production, your life becomes hell. So maybe Elastic's gotten better, but like balancing shards and all the cluster management stuff just never really worked right for me. So the thing about Elastic is all it's really doing is taking your normalizers from the input side, converting those into a Lucene index and making the Lucene index searchable. That's basically the core of it. So if you take away all the things you don't need, all you really need for large-scale data lookups is prefix-based searching. You need range searching and prefix searching. So for example, if we're taking a database of every IP address in the internet, the main thing you care about is like for this IP and for this subset of IPs, what's there, right? I just want to query 8.8.8, or I want to query 192.168.0/whatever. Anything that does keys, that does very efficient key value storage on the key space that lets you do range queries, like anything LevelDB based or RocksDB or Mtable, or there's lots of other platforms that are very similar these days. Those are all great things to use key value stores for. The other nice thing about INET data or the internet data processing is generally it's not changing. You're doing a snapshot on time. So you're not going to store multiple revisions for the same key. You're just going to store a one-time snapshot for this time and this point in time. So all that kind of leads to the conclusion that you don't want a live database of all this data. What you want is a flat file that you can really efficiently query. And the best way to create a flat, efficient query file that we could find at the time was Mtable, which is built by the guys who built Farsight's DNS database. So they have this huge passive DNS database index. And you're talking about billions and billions and billions of queries, and they're all being done every single day. So how do you efficiently query that? Well, you push it down to like a LevelDB format, and you have a very efficient key value store. And basically, you just start off with, for the keys, sorry, let me roll back a little bit. The hardest thing about using a key value store is structuring the keys so they make sense. So if you're querying an IP space, it's easy because an IP address is basically a 4-byte octet for IPv4. So, 1.1.1 is 0x1, 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 0x1. That's all there is to it. So if you're querying for IP space, you can literally just start off, show me the keys that start off with 1, and everything below that basically maps out to 100/8. And same thing, 1.1.00/16, that's byte number one, and that whole key range. Where that doesn't work so well is when you're trying to do an inverse query. Like, let's say I've got a big database full of DNS queries, and I want to search for them based on everything underneath the current subdomain. So google.com, for example. Well, you can't store it as google.com because your prefix search on a key value space would be G star, O star, O star, et cetera, right? So it doesn't really make sense to do that because you only find domains starting with that prefix. You don't want host names starting with a prefix. You want host names ending with that prefix. So the trick there with most key value stores is you calculate a forward lookup, and then you also calculate a totally duplicate version of the database with the inverse query. So you store that as com.google.hostname. And now you search for com.star, com.google.star, et cetera. That also works for IP space and any kind of IP to name mappings or named IP mappings. So what INET data does is it takes all the Sonar FDNS data and it calculates the forward mapping. So to calculate the forward mapping, it goes through all 2.4 billion records. It sorts them all into a nice big sorted list using all your CPU cores and all your memory that you'll give it, and then it flattens that thing out. And then it takes that flat list and inverts it and calculates the opposite versions of that. So it takes every value pair and it inverts those for the keys and combines all the light keys as well. So let's say you've got 4 names that map to an IP address. You'd have one entry on the forward lookup of that IP address with 8.8.8 or whatever the prefix is going to those 4 names. And then on the flip side of that, you'd have 4 different names that all happen to map to the IP address, and they'd be in reverse order for the hostname format. So by using those inverse keys, by inverting the key space, by doing all the big sorts and crunching and data mungling on that stuff, we end up with a much more efficient way to query that data without having to keep a full online database. So I keep about 9.5 terabytes of Sonar FDNS data locally, and I can query it all in like less than 20 milliseconds locally just off a flat file, and there's no servers to manage. Like it doesn't, there's no booting up of servers, there's starting it, there's no backups, there's no maintenance on it. It's just a flat file on a disk, and it's crazy fast.
Cool. Okay, so in the past, you've talked about using whois data to correlate domains that your target owns. But with GDPR and default privacy controls that are enabled when you purchase a domain, what techniques can you use now to figure out the list of domains that your target owns?
There's some ways to do that, but it's tricky these days for sure. If you look at historical whois context, there hasn't been a legal way to get bulk whois registration in a very long time. There's not a straightforward path to it. There's ways you can buy the data, but the way that the people that you're buying the data from gather it may be breaching terms of service. So all of the best whois providers out there, I'm not going to name names because I'm basically saying they're doing things that are probably illegal. All the data they're selling you is gathered by scraping third parties and using API access or combining different data sources. So those providers for the last 10 years or so have all been kind of gray market to start with, because all the data they're gathering under a license that doesn't allow them to do what they're doing. At the same time, the incident response folks desperately need that data to find like domains and similar registrations. So that's kind of been the push and pull of that so far. So the changes that came in with GDPR with removing all the contact information and things like that for domains, they didn't really have that big of an impact because all that data was already pretty well buried anyways. There wasn't a lot of really good data happening, because all the providers were pushing back against the bulk whois collectors. So from a bulk whois and domain registration standpoint, there's not really a good way to do that today that uses the whois information. However, there's lots of other good things you can use to correlate ownership. So examples of that, anytime you use an Amazon ELB, for example, like you're using a load balancer on Amazon, every ELB has a unique ID, and every host name going to that ELB will resolve to the same CNAME. So if you go through like the Sonar FDNS data set and you look for every DNS name whose response resolves to a CNAME, and that CNAME ends in an ELB, you can quickly identify all the different host names are all going to the same ELB ID, which by definition are owned by the same Amazon account. So we know that all those domains are related just because they're going into the same account. So you can use tricks like that. Obviously, there's things like the Google Analytics tag ID is used a lot by incident response folks as well. So when you see the GA Analytics ID across multiple domains, obviously they're being managed or at least somehow related to the same entity that has all those together. So you use things like that. You use similarities in hosting providers. You use cloud-based identifiers that are shared across multiple disparate domains. IP space, of course, is still pretty well shared. So if you see multiple host names going to the same IP address and it's not a shared provider, they're probably the same owner of both. So yeah, whois itself doesn't really work so well, but it's kind of been dying for the last 10 years anyways, and it's been getting more and more expensive to get good data. So that's kind of where things are.
Okay, can you tell us a bit about Rumble? What do you do there, and talk a bit about fingerprinting after you do the scans?
Yeah, sure thing. So last 20 years, we've been doing a lot, kind of bouncing between product development in the security space, things like Metasploit Framework, Metasploit Pro, Breaking Point products, MSSP stuff, working at Rapid7 for a bit, and consulting work. So working at MSSP, doing red team work. Even when I was at Rapid7 working on Metasploit, I was still doing some red team work for fun. And then for the last few years, I've been working with the Traders partners, which I still work with. They're awesome, doing billable work for our clients on that side, which is mostly red team and pen testing and things like that. So the biggest challenge we ran into in almost all those scenarios, and the biggest challenge we run into in security product development, is initial discovery. So you want to go hack some stuff. Great. Okay, what are you going to hack? Like what IP space? What's your scope? Like what services are out there? How do you quickly get the lay of the land for what's out there? And for years, it's been things like using Nmap for the last 20-something years, Zmap, Masscan, et cetera. And those are really good at telling you what application is running on a given service or what protocols are available. But what they don't really tell you is what a device is. Nothing is coming back and saying, hey, Nmap will tell you, hey, this device is running Linux kernel 3.18.4. That's awesome. Good job, Nmap. But it's not going to tell me, hey, it's a printer. And so what you really want as a security professional when you're looking at a brand new network is to be given a list of what's actually on the network, not necessarily all the different components that make up those devices. So that's kind of the premise behind Rumble, is that it's active scan, it's uncredentialed, you can do it quickly from almost anywhere, you can drop an agent in, you can use the command line scanner, and you can scan huge networks really, really fast, and all it really focuses on is telling you what those devices are and possibly what services are open. But it's not really a security product so much as an inventory and network discovery product.
Okay, so let's talk about you mentioned that Rumble will tell you what the product is. So you're doing some sort of fingerprinting. How is that, like if you're going to compare that to, let's say, an Nmap scan, where it has like signatures, or it has like the NSC scripting where it will interact with the server? How are you doing something similar?
Yeah, similar. So if you look at Nmap has a few different fingerprinting layers. It's got your TCP/IP fingerprinting, which does amazing work. That's built on 20 years of cool fingerprints. You've got your application fingerprints themselves, the service fingerprint part, the RPC database fingerprints, and then you have things like NSEs that'll go through and gather more information per service. Each of those fingerprints is trying to tell you what that service is or what that OS is, but they're not really designed to tell you what that device is. So as far as like the total outcome of those fingerprints is to identify points of attack at the service level or at the OS level, not necessarily at the device level. If you look at other tooling out there, things like Nessus and other vulnerability scanners, they really focus on identifying vulnerabilities in services too. They don't really tell you what the device is. So what we're trying to do with Rumble is identify not just hey, this thing has this port open and it's got probably this Linux kernel, but also this thing happens to be a ubiquity router or an access point. The way that we do that today is we build on the Recog database, which is open source. It's still managed by Rapid7. And Recog is neat because it actually started off as the proprietary fingerprint backend for the Nexpose product. So from around 2002, 2003 or so, the Nexpose team started putting together this XML database full of regexes, which it's better than it sounds. And by around 2013 or so, I guess 2014, we had this internal effort within Rapid7 to take that database they've been working on for years and make the whole thing public, and then make Metasploit Framework and Metasploit Pro both use the same database for fingerprinting. And the cool thing about that database, it doesn't really care what you're fingerprinting. It just cares that there's a field that you can feed it that matches against a regular expression that it can then emit a bunch of assertions. So if you give it like a HTTP server banner, it'll come back and say, okay, I know this thing is Microsoft iOS, if you feed it Microsoft iOS 7.5, it'll say, okay, great. Just based on that banner, I know it's running Windows. I know it's running this version of Windows. I know this particular banner is Microsoft's web server, and I know it's this version. So you can emit all kinds of cool information about the asset just by looking at a single service field. So take that approach, but then apply that to 47 different service fields across tons of different protocols. And that's what Recog is. It's these big databases of fingerprint matches that, depending on what it's matching against, it can tell you anything from a kind of Nmap style fingerprinting, like this device is running this particular service in this version by this vendor, or it can tell you things a little like one step further, saying, no, the OS of this device, this is actually a, Cisco NetScaler firmware 7, or you go one step even further and say, this is a virtual appliance by this particular vendor, and being able to tell you a whole lot of information about it. So some of the fingerprints that we've contributed to Recog are things like the TLS fingerprinting. So subjects and issuers of TLS certificates actually tell you a whole lot about a device. So we can read the TLS subject of a Google Chromecast web service on port like 8009 and tell you the model number, the serial number, the Bluetooth MAC address of the device, all kinds of stuff just from the TLS subject field, which is great. So those are the kinds of fingerprints that we focus on. It's how do we identify a ton of information about a device just by looking at a single protocol field like that. Other things that we've worked on that were already there, but we've contributed more to are HTML titles. So just linking the web page title of a given web page, you can often tell you exactly what that device is. Like, hey, this is a HP printer, this is a Netgear switch, this is a Cisco router, just based on the title of those pages. All those different vendor appliances out there, like vendor appliances or vendor systems that ship as virtual appliances, those tend to be really easy to fingerprint through web page titles. And of course, there's tons of other ones. Like we contributed the favicon database. Rumble contributed that to Recog recently. And so that was a neat effort, because what we did is we took the existing entire Rumble data set that we had, all of our beta users, all of our other stuff, and we looked at all the existing fingerprints and then matched all the web servers across the entire set. And we said, okay, great. Now on all those systems out there, let's grab the favorite icons of all those devices and report the MD5 sum of the favorite icon. And now we can automatically generate fingerprints for all the known stuff that we'd already fingerprinted. So we used all the existing Recog fingerprints to generate new fingerprints for the favicons, and then we were able to basically quickly produce about 200 new fingerprints from scratch that way. And it still took a lot of manual work. It was about 16 hours of just labor going into that database to make it as good as what it is. But now we have the best favorite icon fingerprinter ever that can fingerprint everything from IP phones to virtual appliances to backup devices to switches to mobile devices and everything else in between.
Okay, and then do you correlate that back to an entity, like a company?
Yeah, each of the fingerprints has the vendor, the product, oftentimes the operating system, the hardware version. We can assert a whole lot of stuff just based on that fingerprint. So now,
I mean, like in terms of like if you were, let's say you were targeting acme.com. Okay, so can you then correlate? You've got a map of, let's say, the internet, what the actual devices are. Now you want to correlate because you want to figure out what your scope is for Acme. So then how are you correlating that back to the actual entity?
Oh, got it. Okay. We don't do a lot of that yet. Most of the work that we're doing in Rumble is all we care about is the IP space. Like, give us an IP range, we'll go scan it, we'll tell you what's on there. We don't do a lot of attribution work yet where we tell you who owns a given space based on those things yet. But favorite icons, are a good way to do that. We don't do a lot of company-specific fav icons today. Like, for example, I don't think we've got a fingerprint for like a generic AWS ELB or anything like that yet. But those are pretty easy to do. One thing you can do, so I don't want to pitch Rumble too much, we're like focusing on the open source side of it. But within Rumble, for example, if you scan a large network, any field that you find on that network scan, and it could be something like the favorite icon hash, it could be the HTTP title, it could be the fingerprint of the SSH key, you can quickly search that and find everything else that matches it. So for example, if you scan a big subnet and you click on just the favorite icon hash and search that, we'll find every other match across your entire data set that happens to have that favorite icon, and we'll show you all of those together in one shot. So this could be a third-party service provider, it could be your internal application. So if you want to find all the development instances of your internal application, you can search the fav icon internally and find all those in one shot.
So how does Rumble differ from companies like Census and BitDiscovery? Is there much overlap between them?
For the most part, we don't have much overlap with folks like that. So, BitDiscovery, Census, Expanse, all the companies are really focused on outside-in discovery. They're really focused on identifying which assets are owned by your company that are on the internet. And for us, we don't really care about that. We really focus on give us an IP space and we'll scan it for you. We help companies identify their internal networks really accurately. So there's going to be eventually some overlap where the folks who are on the external space want to do more internal. And of course, we've got a lot of customers already that are using Rumble for external network discovery and external network asset inventory. But the real key difference right now is that we're super focused on internal asset discovery. And because of that, the protocols we look at, the way we do probing, the way we do matching, the way we do asset correlation is very different from how those companies look at entities. Most folks who are working on the external side, looking at the outside in perspective, they really have to focus on web applications as their primary identifier for an asset. So many things on the internet are just a website, basically. And so they really focus on what web services are exposed, what applications are behind those services, how are they authenticated, and all the other weird, crazy stuff like your IP cameras and your DVRs and your smart televisions and that kind of stuff. They don't see very much of that at all, unless your network is horribly misconfigured. Whereas that is our bread and butter on the Rumble side. We track all the weird OT clinical stuff. We've got tons of hospital users. We've got lots of oil and gas folks. So we look at all the weird, bizarre devices that most people are too scared to scan, that we scan just fine because we have a custom scan engine.
Last question I want to ask you is about a contrarian view you have in AppSec. We discussed this a bit before the show. What are your thoughts on that?
So I feel like if you look at all the way all the trends are pointing right now, everyone's saying, hey, we're moving to SDN and cloud networks and cloud hybrid and beyond security and beyond corp security. The idea is that the local network as it currently exists is going away. And that's what everyone's kind of looking towards. And even building a new product is saying, we are going to build for a world where there's not much on the local network anymore. That's just kind of where all the trends are going. Now, on the flip side, though, kind of what makes this, to me, a lie is that you're seeing more and more vendors putting more devices on our local networks. We're seeing our Nest cameras, we're seeing our home voice assistants, we're seeing all these different IoT devices and blinky doodads that are all run locally on our local network by definition. So on one hand, all of our security development is really planning towards this unmanaged, mostly external only environment. But on the flip side, we're putting tons and tons of new devices on our internal network and we're managing them even less than before. So if you want to call it the contrarian view, my view is that, yes, the cloud's important. Yes, we're going to see less desktops on LANs, but we're still going to see a ton of devices on corporate networks. They're not going away anytime soon. And if anything, they're going to get bigger and denser and weirder and even more unmanaged as we go forward. So that's my view with Rumble. I feel like Rumble helps solve the problem of identifying what's on your local network, even if it's not on your local network. It's multiple hops away. You can generally return things like your MAC address, your host names, give you a pretty good idea of what a device is, even if we don't have any credentials to it, even if it's multiple hops away from where we are.
Very cool. All right. Thanks, HT. That's it for today. If you have any feedback or questions, then contact me at podcast@breachsense.io. As always, the show notes are on the website as well, breachsense.io/podcast. And if you got value from this episode, then please share it with a friend. See y'all next week.